I'm meteorologist, storm chaser, and author Serena Arnold. We're here to answer your questions from the internet. This is Severe Weather Support. At Barb's Loco says, where is Tornado Alley? So Tornado Alley is Texas, Oklahoma, Kansas. Tornadoes occur in these locations April, May, June. Now we're seeing a little bit of a shift where Tornado Alley is moving further east as well because we have moisture from the Gulf that comes up. You also have cold, dry air come further down, and that warm air and cold air coming together is what helps to cause thunderstorms. And the reason that we are seeing this eastern migration of Tornado Alley is mostly because of climate change. At Olivia Frog says, how the f do we predict weather? How do we just see the future and know what the temperature is? So the way we're able to predict the future and tell you what's gonna be happening is through weather models. A whole bunch of equations that are thrown into a computer. They are run at government institutions or universities and research facilities. They're taking in what's happening with the atmosphere right now. They're applying it to these equations that we know about the atmosphere and outputting information about what's gonna be happening in the future. So then your TV meteorologist can log onto their computer, pull up these different websites, and actually see what's happening in those forecast models. Even the free weather app on your phone is usually being tied back to one specific forecast weather model. We as meteorologists have to be able to figure out which model are we going to use in what situation. We know different forecast models have different strengths and weaknesses. Some are really good within the next 12 to 24 hours. Some are much better when we're looking out 5 to 7 days. Some are better at forecasting hurricanes. Some are better at nor'easters. And some perform differently in different locations around the world. Weather forecasting is really hard. Here we are, this big rock in space. We've covered 70% of the surface with water. Then we've got this crazy gas around the entire planet that's our atmosphere. We're spinning at 1,000 miles an hour as we're rocketing through the solar system. The sun is roasting one half and the other half is facing the vast void of space and is cooling. And now you want me to tell you what's gonna be happening in 5 days? At Dju asks, tornadoes always gonna confuse me because how the F do they happen? So you telling me the wind just throws that ass in a circle? Scientifically, it's kind of what happens. This is a supercell thunderstorm. They rotate counterclockwise. And these are the storms that are capable of producing tornadoes. Right here under this rotating part of the storm that's called a mesocyclone. With all the circulations, the updrafts, the downdrafts, the rotations in these thunderstorms, this is actually also a very large updraft area. You create a void down here and that creates an area of low pressure. And this is the area that forms a tornado. So typically about 1 out of every 10 storm chases actually results in seeing a tornado because they are incredibly hard to forecast. This storm could be capable of producing a tornado, or maybe not. Tornadoes can last for just a couple seconds at a time. Sometimes tornadoes can last for an hour and go for miles and miles. Becky Lou says, why are hailstones a thing? Whose idea was it to hurl tiny blocks of ice from the sky into our faces? When you have a strong to severe thunderstorm, the updrafts in that storm are incredibly strong. And so it takes these little water drops and it launches them up really high, way above that freezing line, and they turn to ice. Then what happens is they fall down back through the storm again, go back below the freezing line, and as they're passing through, lots of water drops are hitting them, and they catch the updraft, and there they go up again for another cycle, and that water freezes. And it does this over and over and over again. If you find a hailstone and you're able to cut it open, most likely it's gonna look like it has rings, like if you cut down a tree, from all of the trips and the cycles that made inside of the storm. So, if you're looking at some hailstones and you find little pea-sized hailstones on the ground, that's great, your storm wasn't very strong. But hail sizes can actually exceed baseball-size hail. Gorilla hail is just another name for really large hail. Grapefruit size or larger, like 4 inches in diameter or larger. And on a storm chase I was on earlier in June, the National Weather Service issued their first ever warning for DVD-sized hailstones. At Shuffleupagus says, wait, Sahara dust affects weather in the USA? Sahara dust absolutely affects our weather here in the United States. The Sahara, here in the northern part of Africa, has lots of dirt and sand. And when we get severe sandstorms, those blow across here and take the sand and bring it over this moist, warm ocean. And we have water that's constantly evaporating, and that water condenses on the sand. And this eventually forms the first clouds that will eventually turn into hurricanes and potentially impact the United States. Ash XX11 says, if someone gets caught in a tornado in their car, do you open a window? Also, do you open windows in your home? People say it's a myth. There's absolutely no need to open the window in your car. It's a common misconception that low pressure is what breaks the windows in a tornado. It's actually the debris, 2x4s, and other things like that the tornado is throwing around. If you're indoors in any building of any kind, get as low to the ground as possible. You want to go to an interior room where you don't have any windows. The more central to your house and the more interior with tight walls around you, the safer you're gonna be. If you are stuck outside, then what you need to do is get to the lowest lying area you can, even if that means lying in a ditch in a field somewhere. Never, ever park your car under an overpass. Might seem like a good idea. You may wanna protect your car from getting any damage, but what's gonna happen is, one, the winds are gonna funnel through there in a really bad storm, but two, other cars park under there. You could potentially be keeping emergency services from reaching people who were just hit by a tornado and badly need medical attention. At GMonster7000 asks, wait, quick question. What are some of the latest technological advancements in tornado prediction? Have they improved warning times? Asking for myself. Yeah. Absolutely. We have a lot of increased radar technology and better notification that has definitely increased tornado warning times. In the 1980s, we only had about 4 or 5 minutes heads up when there was a tornado warning before a tornado would actually be occurring. Today, that warning time is up to on average 13 minutes, and there's some instances even where we are being able to give tornado warnings almost a half an hour before a tornado. The technology that's making that happen is drastically improved radar data. So this is a radar image of what a supercell thunderstorm looks like. Not only we're improving how frequently we're scanning the sky, but we're also getting more detailed information back on that storm. We've gone from them looking in the atmosphere every 8 to 10 minutes down to every 4 to 6 minutes, and in some instances even more frequently than that. And it's with that increased radar technology that allows us to get a better picture of that storm. At Phil Reads News, so have you been able to recognize patterns or relations between the radars and frequencies and the weather? You know, see a certain radar LiDAR pattern, then you know to expect higher low pressure, tornadoes, etc. What's interesting about looking at LiDAR and radar and stuff like that is they are tools to help us understand what's going on in the atmosphere right now. This image here shows radar reflectivity. Weather radar is sending out radar beams and they're bouncing off of the little raindrops and water drops and coming back, and what it tells us is in decibels what is happening. Basically, it's showing the intensity of the storm. These radars are located across the country. The radar is housed inside of a domed tower. You see them a lot of times at airports or just outside of major populations. This image here on the other side shows us a velocity image, and this tells us whether things are moving to or away from the storm. And this red-green difference we see right here is called a couplet. It's telling us all of this is moving away from the radar except for this one little piece that's moving towards. What that's indicative of then is rotation and could mean that there's a tornado there. This comma here on the right is the hook echo. This is the mesocyclone. What you see above this hook is where the rain is and where the downdraft is. The News Box 1 asks, what is the difference between a violent tornado and a regular tornado? Does a violent tornado mug you after blowing everything over? Not quite. So there's different scales of tornadoes. Weak tornadoes, or there's EF0 to EF1 tornadoes. They typically don't last very long. The wind speeds are relatively low, sometimes less than or around 100 miles an hour, which for a tornado is actually pretty small. EF2s and EF3s are strong tornadoes, and then our violent tornadoes do account for 70% of all tornado fatalities. In an EF4 or an EF5 tornado, wind speeds exceed 200, 300 miles an hour. The May 3rd, 1999 tornado in Moore, Oklahoma had a mobile radar unit measure wind speeds at over 300 miles per hour. At Schaffernaker asks, what are El Nino and La Nina and how do they change the weather? What these are sea surface temperatures of the Eastern Pacific, somewhere between Central America and South America, very close to the equator. We monitor the sea surface temperatures there because they're either in an El Nino phase, which means they're a couple degrees warmer than they should be, or we are in a La Nina phase and they're a couple degrees below where they should be. Now, these El Ninos and La Ninas have very large effects on our weather. So for example, during an El Nino year, we can see certain parts of the country be wetter than normal. Other parts of the country will be warmer or drier than normal. The biggest driver that we see with La Nina and El Nino is how they affect what happens in the Atlantic Ocean and how they impact the forecasts for our hurricane seasons. At TruthScant is asking, why is AccuWeather predicting a supercharged hurricane season in 2024? Do they know something that we don't? Yeah, actually they do. So with this upcoming hurricane season, the Hurricane Center, Colorado State University, Atmospheric G2, all of these locations are forecasting an above average hurricane season. First of all, the waters in the oceans right now in the Atlantic and the Caribbean are darn near record highs. Warm water is the fuel for hurricanes. It's what makes them strong and it allows them to last for a really long period of time. The second reason is we spent last summer in 2023 in an El Nino year. El Nino years are known for reducing hurricane activity in the Atlantic. The bad news is that we are transitioning from an El Nino year to a La Nina year. It means those sea surface temperatures in the Eastern Pacific are going to be colder than average. When that happens, it actually decreases the amount of wind shear we see in the Atlantic Ocean and is also something that leads to an increased hurricane season. So hurricane season begins June 1st and goes all the way through November 30th. And within that time frame, in a typical year, we see about 14 named storms. About 3 of those become major hurricane, which is category 3, 4, or 5. For 2024, the experts are forecasting that we're going to see more like 23 named storms. So the number of named storms we're forecast to see this year, as well as the severity of them, is higher than what we've ever forecast before. At Starbucks asks, are storm chasers adrenaline junkies, or are they doing real science out there with all those crazy gadgets and gizmos in their storm chasing cars? All of us are a little bit of adrenaline junkies at heart. Can't deny it. It's something that we do absolutely love. The toolkit for a storm chaser can vary far and wide. We definitely all have cameras. We're looking for weather data through redundant sources. So we're getting warnings on our phones and alerts are popping up. We're getting texts. We can pull up radar data on computers, but many of us also have weather radios with us, because if you get into an area where there's no internet, there's no cell phone reception, they will announce when warnings are issued and the locations that those warnings are for. Another thing that a lot of storm chasers will have with them is different types of anemometers, a fancy word for something that measures the wind speed. You're going to see anemometers like this one that are both measure the wind speed with the propeller and the direction of wind. One of the things that people are most interested in doing is collecting weather data from inside the tornado. Sometimes you see people shooting rockets into storms, flying drones very closely nearby to storms. There's some research teams where their goal is to get out in front of the tornado and put these weather instrumentation dishes that are really, really heavy out on the ground or in fields with the purpose of having a tornado come over them, suck it up, kind of like you saw in the movie Twister. That's actually based on a real scientific experiment that happened about 30, 40 years ago. The actual vessel, instead of being named Dorothy, was actually named Toto. At Mello Malebo says, weather forecasts always mention it's going to be partly sunny or partly cloudy. What's the difference? I feel your pain there. But to help you understand this better, what we're gonna do is we're gonna imagine the sky above us is like an upside down bowl, like a big dome. We are gonna divide it into 8 sections. This is how us meteorologists look at the sky. If there's no clouds present and all sections are clear, we're gonna go ahead and call that clear. If, however, we take one of these sections and we fill it with clouds, now this one section is going to tell us that this is mostly clear, because now we have 1/8 of the sky that has clouds in it. If we have 2/8 covered, this is now mostly sunny. Here's the handy dandy cheat sheet with all of its fractions. Partly cloudy is 3/8 of the sky obscured by clouds. Partly sunny is 4/8. But if you have all 8 of the sky covered in clouds, it's just a good old-fashioned cloudy day. At Kid Chris asks, in the movie Twister, the EF5 is so strong that it destroyed everything, yet the 2 main characters used leather belts tied to a pipe to prevent them from blowing away. I'm starting to think that shit was fake. Yeah, absolutely, it was. So this was supposed to be an EF5 tornado, the strongest of all tornadoes. They wouldn't have been able to hang on with just leather belts. There would be an incredible amount of debris flying around in there. We're talking about entire roofs of houses, and they would unfortunately have been hit by a lot of that debris. So in that movie, which is one of my absolute favorites, don't get me wrong, you see things like cows fly by. Tornadoes are able to pick up cows. They are able to pick up tanker trucks. They're just incredibly, incredibly powerful forces of nature. So in some ways, the movie is accurate in what it shows you and what the tornado is capable of moving or picking up, or the damage that it causes. I Like Corn wants to know, how accurate is the science in the new Twisters movie? Can we actually disrupt tornadoes in real life? And WTF, twin tornadoes can combine into one? Like what? The odds of 2 tornadoes being able to combine into one are pretty slim.
We got twins! Twins! combining.
What's more likely to happen is that their different rotations would disrupt each other. They are not going to form some super tornado. Now, we do see out in the field storm chasing 2 tornadoes happen at once from time to time. It's super rare, but you can have a main tornado and outside of that have satellite tornadoes that form that are much smaller and much weaker tornadoes. As for your second question,
you think you can disrupt a tornado?
Can we actually disrupt tornadoes in real life? Not really. The technology is not there yet, nor the knowledge to be able to control the weather in any way. The absolute closest we can get is through some very basic cloud seeding, putting some chemicals into the atmosphere, and they're naturally occurring chemicals, and allows condensation to happen and allows storms to precipitate out or to rain. That can increase precipitation that a storm is going to put out by 10 to 15%. So the effects of cloud seeding are super negligible, and that's really the only thing we can do these days to kind of control the weather. This is my handle says, what causes heat waves? I can't figure it out. Heat waves are when you have very hot air persistent over a location for a very long period of time. Sometimes you can have heat waves that form, say, along the Gulf, where you've got strong southeasterly winds or flow that keep other storms away. You have high pressure there, and the sun just beats down on you and allows that humidity to pour in and the temperatures to climb. And heat waves can be particularly deadly, not so much because of the actual ambient temperature of the air, but due to the heat index. So that's when you combine the temperature of the air plus the moisture of the air, the humidity. If it's extra humid, the sweat on your body, which is your natural air conditioning system, doesn't evaporate and doesn't allow you to cool. So it may be 95 degrees out, but with really high humidity, it could feel more like 105. Actually KD asks, so a hurricane is coming and I can literally smell it. It smells exactly how the sky smells before a tornado. Who else can smell storms? Actually, when you're smelling rain, oddly enough, what you're smelling is some of the different pollutants in the atmosphere. So when you have this warm rain fall down, particularly on asphalt, you can actually have a chemical reaction that increases some chemicals in the atmosphere temporarily, which are the ones that you can smell, and that's why you can smell rain. Sometimes people can feel it in their bones or in their muscles. Our atmosphere is really heavy and it's pushing on us constantly with about 15 pounds per square inch on your body every single day. But that can vary. When we have high pressure, that may be more like 16 pounds per square inch, and with low pressure, it's more like 14. That air acts like a natural compression instrument for us, and when we have lower pressure, less air is pushing on you, you have less pressure on your joints and your muscles, and this is why during low pressure, some people feel achiness or soreness in their muscles, especially from old injuries, and why some people also get headaches. Hunter T wants to know, how much energy could we generate from a hurricane? Now, it would be really hard to capture energy from a hurricane, but hurricanes are incredibly powerful. People estimate that a hurricane is able to release as much energy in a day as the entire world consumes in a day. Some people estimate the average life cycle of a hurricane can generate as much electricity as 10,000 nuclear bombs. So Baby Gorgeous asks, question for meteorologist friends, what happens when 2 hurricanes hit each other? Do they break up or combine? If 2 hurricanes were in fact to hit each other and collide, they would actually break down the systems in each storm. Hurricanes are a little bit like an engine, and they run on a very specific fuel, which is that warm ocean water. They have set circulations in them, and this is what allows a hurricane to last for a really long period of time. If they were to hit, it would be very similar to 2 cars on the highway colliding. It's not like it would form some supercar, you would just have 2 really wrecked cars. Rice Jones asks, can lightning strike the same place twice, and can tornadoes cross rivers and mountains? Yes and yes. Lightning can absolutely strike the same place twice. It can strike the same place twice in the same storm. Now, it doesn't necessarily have to, but there are some places around the world that actually receive multiple lightning strikes within specific storms. Typically, they're at higher elevations. The tallest buildings in New York City can be hit multiple times in a single storm. And your second question, can tornadoes cross rivers and mountains? Yes, absolutely. Now, with mountains, you could potentially disrupt some of the airflow that's involved with a tornado and some of the supporting structure of the thunderstorm itself, but I have absolutely seen tornadoes occur in mountainous locations, and tornadoes do not have a fear of water. They will absolutely cross it without any problem. Anyone who tells you a tornado will not cross a body of water, a river, or anything like that, it's a complete myth. Faded Fairy asks, why does thunder sound like the world is ending? Thunder is actually just hot, expanding air. When that lightning strike occurs, it heats up the air around it so fast, it actually breaks the sound barrier, and what you're hearing is basically like a sonic boom. And and that rumbles through the atmosphere. After you see the lightning, count 5 seconds, and after 5 seconds, if you hear the thunder, that lightning strike was 1 mile away. After 10 seconds, that lightning strike would have been 2 miles away. One of the most important lightning safety tips out there is the 30-30 rule. A lot of lightning comes out the backside of thunderstorms. After you see the last lightning strike, wait 30 more minutes before you go outside. At Thichuya asks, how much energy does a lightning strike have? Lightning strikes can have various amounts of energy in them, but I can tell you the lightning strike itself is 5 times hotter than the surface of the sun. Lightning is just a release of static electricity. When you were a kid and you used to rub your bare feet on the carpet and then touch your sibling and zap them, lightning is very similar. Lots of ice particles are rubbing together, creating static electricity. You'll see this strike that goes from the sky down to the ground. It's the electricity trying to balance itself out again. Areas of low concentration of electrons trying to balance out with areas of high concentrations of electrons. If you're ever standing outside during a storm, or maybe there's rain nearby, or maybe even like a town over, and you start to feel all the hair on the back of your neck stand up, that's a bad sign that you may be hit by lightning. If you're an open body of water like the ocean or in a pool and a thunderstorm moves in, please get out of that water and go inside, because water is a big conductor of electricity. And so if lightning hits that pond that you're in, or that pool, or that body of water, it could electrocute you as well. So these are all the questions for today. Make sure that when you're out there, you're weather aware and not scared. Thanks for watching.